Hey class, this video is going to go with 10.1c geometric series. All right, so we talked about geometric sequences in the last video, and if you remember, a geometric sequence is any sequence that is changing by a constant multiple. So like the sequence 2, 4, 8, 16, you're multiplying by 2 every time. And when you're multiplying by 2 every time, that means your common ratio is 2. So a series is defined to be a sequence that's being added together. So the difference between a sequence and a series is that a series is a sum of a sequence. So a series is the sum of a sequence. And we might want to find the sum of a sequence for multiple different reasons. I'll do a couple examples down at the bottom to give you some real life applications. So here we go. We have a special formula. If it is a geometric series and it's finite, so we have to say that has a specific number of terms, we can find the sum. You can't find the sum of an infinite series because it goes on forever. So consider the series 1 plus 5 plus 25 plus 125. So that goes with the sequence 1, 5, 25, 125. So in that sequence, you're multiplying by 5 every time. So that means your R would be 5, your common ratio. And then here is our formula. S sub n is a sub 1 times, and it's 1 minus r to the n over 1 minus r. So find the sum of the first 10 terms, means you want to find S sub 10. So the first term in this sequence is 1, and the R is 5, because that's what you're multiplying by every time. Since I want the first 10 terms, that means my N is 10. So plugging that in would be 1 times, and then it's 1 minus R to the 10th power over 1 minus r. Okay. And then before I put this in my calculator, I usually evaluate the denominator, but you don't have to, especially if you're using Desmos. You cannot add the numerators, the 1 minus 5 to the 10th and say negative 4 to the 10th, because you have to follow the order of operations. So you would have to do 5 to the 10th and then 1 minus that. If you just put it in the calculator exactly like you see it, you should be good to get the right answer. So one thing is you will need parentheses around the numerator. So you'll do 1 parenthesis, then another parenthesis, then 1 minus 5 to the 10th power, then hit the arrow over to close that parenthesis. Divided by, and then you can do 1 minus 5 in the denominator, and then close that parenthesis. So it should look just like that. And so it's, put some parentheses or commas in there so I can read it. 2,441,406 would be the sum. So make sure you practice putting in the calculator and you're getting the correct answer for that. So the 10 terms of that series add up to the 2 million. All right, the next one. So here we have the series 1 plus 3 plus 9 plus 27. That goes along with the sequence 1, 3, 9, 27. So if in the sequence you can see that you're multiplying by 3 every time. So to find the sum of the series, you're going to use your common ratio as R is 3. Then I want the sum of the first 12 terms. So that means my N will be 12. And then the first term is 1 again. So if I want the sum of the first 12 terms, that's what S sub 12 stands for. It's the first term times 1 minus r to the n power, so 1 minus 3 to the 12th, over 1 minus 3. Now when you put this in, you will need the double parenthesis for the top. So my 1 really isn't necessary out front, but parenthesis, then I'm going to start the numerator, so another parenthesis, And 1 minus 3, use a to the b to get the exponent to the 12th. And then divided by 1 minus 3. And then close that parenthesis. So 1 minus 3 to the 12th and 1 minus 3. So 265,720. So just using the formula, identifying the key pieces, and plugging it in. Okay, we'll do a couple more here. Sum of the first 10 terms. The first term is 2. This is 2, 8, 32, 128. So you're multiplying by 4 every time. So R will be 4. And we want the 10th term, so to the 10th power over 1 minus 4. Plugging that one in. It's 2 out front this time. 2 parentheses. 1 minus 4 to the 10th. Close that first parenthesis, so I did have to arrow to the right and then close it, divided by 1 minus 4, arrow to the right, parenthesis. 699,050. Sum of those series. All right, this one is sum of the first 10 terms again, so S sub 10. The first term is 1. 1, 2, 4, 8. You're multiplying by 2 every time. So R is 2, and then it was the 10 terms, so 2 to the 10th over 1 minus 2. So 1, parenthesis, 1 minus 2 to the 10th, arrow over, parenthesis, divided by 1 minus 2. Whoops. There we go. 1,023. So that one's a smaller series. Okay, so when would we use the sum of a series? So it might be something like this. Mr. Smith likes writing lots of exam questions. He usually starts out with a semester with only 10 questions on the first exam. But for each subsequent exam, he writes 1.5 as many questions as were on the previous exam. How many total questions are there by the 5th exam? So, since I want to figure out the total number of questions he's written over 5 total exams. So each exam he's putting on 1.5 times as many. And so how many has he written in total after 5 exams? So the sequence is he starts out with only 10 questions on the first exam, 10. And then on the next exam, he writes 1.5 as many. So 10 times 1.5 would be 15. Then 15 times 1.5, whoops. Now he has 22.5 questions. And so forth. I think that's right. So if I'm going to find the sum of the first 5, or the 5th exam, I want to find S sub 5, where R is 1.5 as many, so 1.5. The first term is 10, and then you are finding for 5 test questions. I was going to look it up and make sure I'm right, but I'm pretty sure I'm on the right track here. So A sub 1 is 10, and then 1 minus 1.5 to the 5th power over 1 minus 1.5. This should give me the total number of questions he's written in all 5 exams together. So we got 10 times 1 minus 1.5 to the 5th power over 1 minus 1.5. And I get 131.875. So I'd say that it would probably be about 132 questions on all 5 exams that he has written, if he started with 10 and added 1.5 as many each time. I don't know why my OneNote crashes like that. Okay, the next one I think is interesting. I changed it from last year to kind of match what we are dealing with in our present time. So a virus that spreads through the country, and the number of new cases doubles each hour. There are 100 new cases to start. Are there 100 cases to start? How many total cases of the virus will there be after 24 hours? So I want to know the total number of cases after 24 hours. So we start with 100 cases, and then it doubles each hour. So now we have 200 cases. Then we have 400 cases. Then we have 800 cases. And I want to know how many total are there. So I want to find the sum of the series after 24 hours. Okay, so that means since it's doubling, your R is going to be equal to 2. I want to know the sum of the first 24 terms, so N will equal 24. And my A sub 1 is 100. I start with 100 people, 100 cases to start. So the sum of the 24 would be 100 times 1 minus R to the 24th power over 1 minus 2. So we started with 100 cases, and it's doubling. So 1 minus 2 to the 24 after 24 hours. And then that divided by 1 minus 2. And then, so we're going to have, it's 1.67777215 times 10 to the 9th. Which means it's so large that it gave me it in scientific notation. So to the 9th means I need to move the decimal over 1, 2, 3, 4, 5, 6, 7, 8, 9. So it'll be 1.67777215, and I have to add 2 zeros. So we got hundreds, thousands, millions, trillions. So 1,677,721,500 cases in 24 hours. So we know that the virus here is not quite spreading that fast, but it is spreading exponentially. And you've seen that exponential growth and geometric sequences are related. So it's important for us to stay home and stay safe, and hopefully not spread it quite as fast. But there's an example for you. All right. Thanks for watching.